It is not always possible to capture all the required data points for a spool from one location. Large spools can be a challenge, or the spool may be in situ where various components block your line of sight. In this video, we will show you how to move the instrument mid-survey so that you can make sure you get good coverage for your flanges and capture all the necessary data points for a reliable report. In this case, we are moving the instrument because an obstruction prevents us from being able to observe both flanges on the spool from the same location. Before we start our survey, we need to set up control points. These control points allow you to create a reference system that can be referred to after a move. You need stable locations surrounding the item being surveyed. You can place the large round magnets found in your device set in magnetic locations and draw a circle around them so you know if they have moved. Do not put all your control points on a straight line. Try to create an imaginary 3D box around the item you're surveying. Here the control point shape improves as we move the points because we are covering more area around the spool. And here the control point scale improves because we are increasing the scale to match the spool. Stand at each setup location and make sure you can see at least 4 control points and the flange detail points. Once you're satisfied this has been set up correctly, you can start your survey. Press the control button. Capture the control points. The order is not important. When the control point criteria have been met, the control and move buttons will turn green. If the buttons turn yellow, it means the control could be better. A move is possible, but try to reorganize the control points to get the buttons to turn green. There must be 4 or more control points. The pipe and control must be of similar scale, and the control must have good shape. Then observe all the data points you can from your first setup. In this example, we can only see 1 flange and 2 circle fits. Press the Move Instrument button. If you press this button and there aren't enough control points in the file, you'll be informed, and you'll need to take more control points. Now, at the second setup location, make sure you can see the control points and the objects being measured. The software border turns red, and most buttons are deactivated. The only exception is undo. If the instrument has not yet been moved, you can undo the move command, if the move is not necessary. The measurement buttons are not yet active. The control must first be measured to ensure that the control point criteria have been met. Again, there must be at least 4 control points. The pipe and control must be of similar scale. The control must have good shape, and how the first set of control points fit to the second set must be reasonable. Again, the order in which control points are captured is not important. When the border turns green or yellow, you can proceed. When the Complete Move button flashes, the control criteria have been met. Press the Move button to complete the move and update the registration. The system will now display the moves report. Overall integrity can be rated as good or fair, with green representing good and yellow representing fair. A scale integrity greater than 1.3 indicates that the control scale is roughly equal to the pipe spool in the design file scale. When shape integrity is yellow, it is greater than 0.2, which corresponds to 1 control point approximately 200 mm off a 1000 mm long line. Green is above 0.3. The maximum residual in millimeters is the largest error in the fit when the 2 sets of control points are aligned using the least squares method. The movement distance in millimeters indicates how far you have moved between instrument setups. Common points indicate how many control points were used in the fit. All survey points are now in the same coordinate system, allowing you to continue your survey. This is a live registration method that includes real-time fit, scale, and shape checks. Live registration means there is no post-processing of multiple setups, and the live flange diameter and PCD checks are updated with all observational data as you take more measurements on a flange common to both setups. There is no practical limit to the number of control points or setups. The control from both setups has been averaged, and only one list of 4 control points remains from the 2 we captured.